and charge up. They have a lithium-ion charge controller on board, which does add to the cost, adds maybe 45 pence, which is a significant fraction of the robot's cost. But the real advantage we get is that we don't have to worry about the kind of power source we're giving the robots, or how many there are. We just have to ensure that the power supply is big enough, it can supply enough current to 30 robots at once or whatever, and each robot will manage its own charge. No one will end up overcharged, or ideally not undercharged if they get there in time. That's also an interesting source of behavioural stuff, because when the robots die, you can use the power, the robots need to continue to live, which gives them an objective more basic than any of the behavioural stuff on top, if you code it that way. So now I'm going to talk about actually building these things. It's a sort of example of mass production at home. 25 robots were built in a single day with 9 people. This is a student house, nothing advanced. We've got sat around our kitchen table there, washing up in the background, but don't look at that. And there are people here who have never soldered anything before. By the end of the day, it was a long day, but let's not let that put you off. These people were soldering sub-millimeter 0603 surface mount devices, TSOP components with 0.4 millimeters between the legs, and reliably too. So we had a very cautious quality assurance procedure. We had one guy who would not give out the chips or the resistors or whatever for the next stage of your build until you've proven to him that the ones that you've soldered on last time are all there, and the board passes some basic tests at each of these important nodes through the construction process. And through that, we ended up with a good way to learn soldering, and believe it or not, 25 working robots after a bit of rework. I mentioned the surplus mobile phone motors, very cheap, but the downside is they come with the eccentric weights on them, which is kind of erratic if you use them to drive robots. So we built this jig to pull the rope, or push the motor through the hole in the weight and discard the weight, because it's virtually impossible to do it by hand, but this really sped things up. The wheels, unfortunately, are the only custom mechanical components. The only part that we couldn't find a commercial off-the-shelf part that we could use instead, maybe a rubber washer or whatever. We had a look, there's nothing out there. So we built a simple tool to essentially press them from rubber sheet, and we used this setup to create about 100 100 wheels in an hour or so, which is not too painful. And there's a little jig there at the bottom for punching a concentric hole in the middle to accept the motor. There's no sort of glue or anything involved, so nothing to gum up your motors. We also have a little programming jig, a little bed of nails here to test the important nodes in the circuit, because connectors are really expensive. So you don't want to use those. Just have some bare copper pads on the PCB and some spring-loaded test pins come down and make contact, and that's a hell of a lot cheaper. So we're going to demonstrate the system to you now. Hopefully it'll work nicely. I shall switch to the video source. I guess the AV guys aren't here anymore. Perhaps the camera's just powered itself off. Oh, excellent, hi. Great. So, sorry I got to a bit late there, but you can see that in these 2/3 of the arena there are these little black and white food tokens. The objective is to push these to the lamp, which is at the very far end, in the third of the arena. That was empty at the start, I promise. Now the robots have no concept of navigation through this space, which is maybe evident. They do know when they've hit a wall because they know that their light bearing hasn't changed for a while. So then there's like a watchdog timer and they back out, do a little random spin and carry on. They do a random walk until they encounter a food token, like this one here. And then they'll endeavour to light seek using a kind of Breitenberg style behaviour. And they'll push tokens to the lamp. I'll invite my colleague Steve here just to tweak the ones which are stuck too horribly, but I want them to do mostly their own thing. The good thing about having 25 robots is that 10 of them can not work very well, and you can still achieve great things. You can see the mood indicator LEDs on the top, and they're reflecting the internal state of the robot. There's red, yellow, and green. The red and yellow may be a little indistinguishable on the video. But they flash red when they're dangerously low on power, then they're trying to avoid the light and get to the charger at the bottom here. So that guy just there, who was just flashing red, thought he was dangerously low on battery power, but has now found some food, and maybe that's more important to him. When the robots have a green LED, they think they've found food, and that engages the light-seeking behavior. They're also always communicating with each other. Whenever they're within a short distance, maybe about 5 to 10 centimeters, they can communicate, and they're asking, or they're transmitting, I last saw food N seconds ago. So this enables the whole community, they average their value with that they've received from everyone else. So through the community, there's a kind of average how much food is there left value, which will gradually drop as all of the food migrates up to the other end. And when the robots all decide that there's not much food left, they'll start flashing green and driving home. That's when they haven't seen food for 30 seconds, or the average of their value with someone else's is under that time. So you can get involved with the Swarm Robots project, the Formica Robotics adventure. They're very, very cheap, as I say, and they're available in the Creative Commons license for the hardware and GPL for the software. You can download them from some URLs which I'll put up at the end. We would like that. Let's say, if anyone's interested in getting into MSP430s, this is a great little development board, because most development boards you buy come with some LEDs and some switches and stuff, which is kind of cool. But these ones can drive around. So I definitely recommend them. There's the excellent open, or almost open toolchain available for development under Linux, the MSP GCC toolchain. Some of the other talks here have been mentioning that set of software, so I'd recommend it for any of you hardware freaks. This one is probably missing a wheel. That's a common failure mode. Yeah? Yeah. There are some spares, I think, in the box down here, perhaps. So, I think that pretty much concludes the demo. Everyone flashing here has decided that there's no more food left. A good sort of third of the food is at the far end, which, ain't bad. And these guys are trying to charge. You see he's losing contact there every now and again. If they can test when they're in contact with the charger, and if you disturb them, they'll back up and try again. So try and hold that one away with your finger, Steve. Yeah, just put your finger in front of him. You see him drive forwards there. And he gets really angry after a while. You're right in front. This is my first talk, so occasional blunders. So I guess we can take some questions, if anyone's interested.
Is this mic on? Yeah, okay. Question, there were units that seemed to behave better than others, got more work done. Were the programs were all the same? What accounts for the difference? Just random chance?
Yeah, that's a good question. There are several factors involved, some mechanical, and an electronic one is battery status. If they're very, very low on power, then they tend not to behave quite so well. Also, mechanical factors such as the metal prongs at the front, they sometimes get bent and introduce some new steering characteristics. And some of the ones charging there may lose contact more often than others because of these sort of mechanical problems. So all of these things sum to change the behavior, and it's exactly those kind of effects that are exciting in swarm robotics research. Another question, perhaps? Does that answer your question?
Yes.
Good.
What are all the differences between doing these things in hardware and between simulating them in software?
I'm glad that question came up because I forgot to mention that. There are swarm robotics researchers who do a lot of simulations, and there are a few who do a lot of hardware stuff as well. The simulations are obviously a very powerful tool to explore these phenomena, but there are new phenomena that arise just as a result of doing it from hardware, which are also interesting. So if you're building a model in software of your robots, you can't possibly think of all of the things it can do. Can't stress that enough. So doing it in hardware teaches some new tricks. Secondly, although these are mostly still used in research, they're just beginning to come into practical applications, and so the pragmatic hardware stuff really becomes important. You can no longer ignore sort of current consumption or any of those factors. Another question, maybe? So you can see they're all quite happily charging there. Can we? You can't actually see them. Maybe we can pan the camera down slightly. But some of you who can see the orange flashing lights there, they're happy robots charging.
It's obscure.
Okay.
Okay. In addition to the virus experiment, did you try to do some artificial evolution on the robots?
No, that would be fascinating to do. We've tried a few behavioural scenarios, but none have involved different bits of code floating through the community yet, and I'd really like to try that sometime. Unfortunately, there isn't a kit available at the moment. The question was, where can we buy a kit, by the way, since he wasn't on the microphone. We may make one available if demand is high. Yes. Maybe we can change back to the slide. If that's
How long does it take for one robot to transmit its new software to another?
Good question. I don't know the precise number, but to completely download code across the link probably takes in the order of 10 seconds or...
Well, it's more like a few minutes, but they don't have to. They don't get to.
Yeah.
They don't just sit there and collect
Okay, my colleague who worked